So Unit 12, Notes 2, again, that's a little bit misleading. This is really day 3 because we spent 2 days on the sum and difference. And so now we're to the doubles. It's really similar to the sum and difference ones in that you get an equation, you draw a picture, you plug into the equation, you simplify stuff. Like, it's pretty straightforward, very similar to, or at least the first half is very similar to what we did yesterday. Double angle identities are used in pre-cal and calculus. In pre-cal, we use the identity to give the exact value of trig functions. That's the first part of today. To prove other identities, we don't really do that much. To manipulate trig expressions, which will help us solve equations, that we will do today. In calculus, so you don't really need this yet, but in calculus, there's times when this makes taking a derivative or doing integration a lot easier. In fact, not even just easier, but possible. Easier or possible. Because of their importance, you need to memorize, sort of. Let me explain these sort of. So the double angle identities. Some of you are just going to memorize them because they're not hard, no big deal. But let me show you where they come from, and that way you don't have to memorize them if you don't want to. Sine of 2x, that's the same thing as the sine of x plus x. Right? And so why would you do that? Except that we have a formula for the sine of the sum. And the sine of the sum formula is sine of the first one, cosine of the second one. No, those happen to be the same thing, but sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Well, sine x cosine x plus cosine x sine x, what does that equal to? Or how many of them are there? 2 of them. 2 sine x cosine x. So there's your double angle formula. Again, you could memorize it or you could get it from the sum formula. I'll leave it to you. I'll just phrase it this way. That won't be given. So you can get it from the sum formula or you could just memorize it and be done with it. We'll do the same thing with cosine. Cosine of x plus x. Let's see, the cosine sum formula is cosine of the first one, cosine of the second one, minus sine of the first one, sine of the second one. So that's cosine squared x minus sine squared x. And then same story. You can memorize those, or you can derive them from the sum formulas. Whichever way makes more sense to you. Tangent of 2x isn't listed on here because instead of using the formula to derive it, most times we'll just do sine of 2x over cosine of 2x. So it's not really like a new formula, that's just tangents equal to sine over cosine. All right, some examples. Given that sine of x equals negative 12/13 and x is between 3 pi over 2 and 2 pi, so let's draw the picture. What quadrant should we draw the picture in? Between 3 pi over 2 and 2 pi. What quadrant was that? 4. And then let's see, sine is opposite over hypotenuse. Where did the negative come from? Which side length is negative? the 12 because it's down. The 13's kind of down. Why not the 13? Or do you know? The hypotenuse is never negative, so you don't have to worry about it. All right, so there's our picture. Sine of 2x is 2 sine x cosine x. So let's just look at the picture and plug in the pieces. Sine of x is negative 12/13. And cosine of x is 5/13. And I'm not even going to, this does not warrant the algebra is hard stamp. But there are people who will miss this for a couple of reasons. One, they'll multiply the 2 to the top and the bottom. But that's not right. That wouldn't be doubling a fraction if you multiplied the top and the bottom. So it's just to the top. And then a few people want to distribute the 2 to both of those. That's not how we multiply. We're just multiplying them all together. 2 times 12 times 5 would be... I'm going to go out of order because I like the 2 times 5 is 10. That makes the rest of the problem easy. Negative 120. And then 13 times 13 is 169. That's it. Draw the picture, plug in the formula, be careful with the algebra. Sort of the same story as yesterday. Draw the picture, use the formula, be careful with the algebra. Part B, cosine squared minus sine squared. So cosine is 5/13. Sine is negative 12/13. Having to write small here. So that would be 25 1/69 minus 144 1/69. We defaulted into a common denominator, so that's nice. And then 25 minus 144 is negative something. 144 minus 25 would be 119. And then tangent is just sine over cosine, especially since we already have sine and cosine of 2x. So negative 120 over 169 over negative 119 over 169. And then there's like 3 different things you could do from there to simplify. Hopefully some of you know how it simplifies from there, what to cross out. Others of you might want to do what we did earlier with fractions, and that is multiply the top and the bottom by 169 to force them to cancel. And there's our answer, 120 over 119. Some of you might choose to keep it, change it, flip it, in which case the 169s would cancel and you'd get 120 over 119. Again, so similar to yesterday for that part of it. In fact, similar enough that I think we can skip example 2. Because again, let's draw the picture, use the formula, plug things in, not really that hard. But example 3, cosine squared of 10x minus sine squared of 10x is equivalent to which of the following? Let's see, cosine squared minus sine squared. That looks like cosine squared minus sine squared. If I put the x's in there, so I'm not worried about the 10x yet, cosine squared of x minus sine squared of x is cosine of 2x. So I doubled the argument. So cosine squared minus sine squared is cosine of twice the argument. So most people, they can throw out A and C. They just have trouble figuring out, well, wait a minute. I know I'm doing something with 2. Is it 5x or 20x? What do you think? From the cosine squared minus sine squared to cosine of 2, double the argument. So what's the argument going to be? 20. I'll walk you through it like that. Hopefully that makes it easier. But a very common mistake is to put b for that one. Because you know you're doubling or halving and you can't figure out which way you're going. But from here to here we doubled. So from here to here we doubled. Alright, on the back, or on the next page of notes, number 4, this is really similar to the most recent test we did, solving equations, except that there's some tricky stuff at the beginning. Find the value of x on that interval that satisfies this equation. But I can't really solve this equation because it's got sines and cosines in it, and nothing squared. But I do know that sine of 2x is the same thing as 2 sine x cosine x. And then now that is very similar to questions we had on the last test. What do you want to do from there? Factor out a cosine. So factor out a cosine. Let's pick on some people. So Samantha, what's left if we factor out a cosine?
2 sine minus 1.
Good. 2 sine x minus 1. So cosine equals 0. Yes, good. 2 sine x minus 1 equals 0. Many of you are just skipping that step and jumping straight to sine of x equals a half, because you see what's happening here. Okay, well these are just unit circle things, and so this is like easy peasy at this point. Right, Gray? Where's the cosine equal to 1/2? Or excuse me, where's the cosine equal to 0?
Oh,
90? Okay, I like that answer. What's that in radians? So that's not wrong.
1/2.
Pi over 2. What about the other spot? 3 pi over 2. Christian, where's sine equal to 1/2? Let's see, 1/2 is the short side. Pi over 6. And then where else? Good. So first step was this lesson. The rest of the steps were last unit. Number 5 is really similar. Place sine of 2x with 2 sine x cosine x. Like really similar. Because what do you want to do next? Isabella, what do you want to do next? I would factor out a sine as well. A few people mess this up on the test. Factor out a sine, then Morgan, what is left?
2 cosine minus square root of 3.
Good. 2 cosine x minus square root of 3. And then, just like we just did, sine of x equals 0. Can I skip a step? What's cosine of x going to be? Root 3 over 2. So more unit circle questions. So Janessa probably knows where the sine's equal to 0. Very nice. Does Gabe know where cosine is equal to root 3 over 2? Very nice. You guys really are unit circle experts at this point. Some doesn't know. Not true. Number 6. Something kind of funny happens on number 6. Funny as in not good, basically. Cosine of 2x equals sine of x. Kind of stuck, except that what does cosine of 2x equal? You remember? You got to flip back and look. Cosine squared minus sine squared. It's like, okay, I guess that's good because I don't have the 2x issue anymore. But now I have sines and cosines. If only I could get rid of maybe that cosine squared. There is a, it's, yes, related to that one, but we don't have to get to that one. It's the easier one. Sorry, Marcus, you wanted to. So cosine squared is equal to 1 minus sine squared. So in place of cosine squared goes 1 minus sine squared minus sine squared equals sine of x. Okay, so I had to do 2 substitutions. One to fix the 2x, and then one to fix the cosine squared. What do you want to do next? You could subtract the sine to this side.
But there's something better.
There's a better way. Okay, let's combine like terms first. 1 minus 2 sine squared x equals sine of x. So Marcus, yes, I can move the sine over, and that would be the, in one sense, the shortest thing to do, because it would only involve one movement. But there's something better to do if we think about what's coming next. You know what's coming next, I guess, is the question.
I'm unaware.
You're unaware. Well, let's move it. Let's move everything to the other side. Now do you know what's coming next? Factoring. Yes. It is the Kate Matthews method of factoring. It's not bubble factoring. I will not call it that.
You can just keep it Matthews.
You can call it bubble factoring if you like. It's got to be 1 and 1. And then it's the double rainbow factoring check method. Or the double smiley face. However you want to think of it, I got to get a positive sine x out of the 2 middle terms. So I need the one connected to the 2 to be positive, and the one connected to the 1 to be negative. That'll get me my factors. Whatever method, whatever name you want to attach to that method. So sine of x equals 1/2, and sine of x equals -1. And again, this is just unit circle stuff. I'll call my name. We just did the 1/2. I think that was Christian that did that. Pi over 6 and 5 pi over 6. And then sine x equals -1. So that would be the down spot. 3 pi over 2. Alright, we're not going to do number 7. It's the same thing. I mean, it's not exactly the same thing, but it's the same process. Cosine of 2x is cosine squared minus sine squared. And then we don't like sine squared, so we replace that with 1 minus cosine squared.
God bless you.
Thank you, and so on. Alright, today's assignment is worksheet 3. And then we'll answer questions from that on Thursday.